as for phase design. In this section, I will present the methodology, the design methodology of my phase shifter, and then I will present impedance matching. In this section, I will present how I can match my phase shifter using separate input section. And for tuning my phase shifter, I use the parameter there. Then I will present the model, and I pass for application to this phase shifter, and I will present the results and finally conclusion and perspective. So nowadays, with the explosion of communication system, we need to robust, flexible, and cheap microcomponents. So phase shifter is a microcomponent in microcomponent system. So it must satisfy this constraint. We have several types of design or architecture for phase shifter: transmission type or reflection type. And in this case, I design or I propose a transmission phase shifter based on distributed transmission line. So distributed phase shifter have good performances and easy to be fabricated. And I use the CPW transmission line, coupler wave guide. So coupler wave guide was chosen. That is characterized by both ground and signal lines are on the same side of substrate. So we avoid to fabricate to add a via hole that can disturb the performance of our phase shifter. So easy to obtain design equation. So our phase shifter is composed by several sections. Each section is composed by portion of transmission line characterized by impedance I and velocity Pi. In each section we add a variable diode that can modify the characteristic of the section of our phase shifter, then modify the characteristic of our phase shifter. So the impedance ZL represents the whole impedance of our unit cell or section of our phase shifter. So we define the X is the ratio between the maximum impedance, the maximum capacitance of our variator and the element capacitance of our transmission line section CI. So to calculate our suitable for our impedance of our portion of transmission line, we can from ZL we can get this equation that represents ZI as function of ZL and X. So we define X, and we can take ZL 50 ohms to get our matching impedance. Then we determine the ZI. As our phase shifter is composed by the design is a periodic, so we can define the Bragg frequency. This frequency defines the limit of our periodicity or our number of cells used for our design, our phase shifter. So we must choose our the minimum background frequency that can give us a lower number of sections and a good performance of our phase shifter. So after giving the branch frequency, we can determine the length of our section and the maximum capacitance that our variator diode can achieve. And we can also define the phase shift given by each section. And by using the ratio C max and C min given by the manufacturer, that means how each variator diode is defined or characterized by the ratio Y. So we can use this parameter to calculate our phase shifting generated by our phase shifter. So, and by using the phase shifting generated by each cell, we can define the number of sections that give all phase shifting. Here, on this side, I present the design methodology used to design my phase shifter. Firstly, I start by giving the specification to the operating frequency, required insertion and return loss, and the phase shifting. Then I give the break frequency. It must be higher than 2 times the maximum frequency of our the maximum operating frequency of our phase shifter. Then, using the previous equation, I can determine the design parameter and go to circuit simulation and the electromagnetic simulation in order to calibrate our model and giving the final calibrate model and fabricate our phase shifter. Then we use the true simulation to correct the error generated in circuit or electromagnetic simulation. So the template input section consists of a section of transmission line CPW that can match our phase shifter between the reference impedance 50 ohms and the input impedance that change the input impedance ZR and change with the capacitance of our variator. So using this method, we can match our phase shifter for all the range of capacitance of our phase shifter, of our variator diode. So this matrix represents ABCD, matrix of input template section. We use MACOM variator diode. So in simulation, we have used this model with the characteristic parameters. So we have designed also programmed an interface, MATLAB interface that permits to from the design parameters or the specification, we can determine all the parameters of our processor before the fabrication. And this simulation, we convert this simulation with electromagnetic simulation to determine the error and calibrate our model. So we have fabricated our phase shifter, and we have we have given a parameter x as 5 and the break frequency 4.8 gigahertz. Then we have determined the other parameters. So the insertion loss. The insertion loss as function of bias. The bias, we have good performances for 5 volts or for 20 volts for S11 and S21. And we have evaluated the performance in terms of S11 and S21 for different frequency, like 1 giga, 1.5, 2, and 2.4 for different value of voltage. So for different value of voltage, so it's the same for capacitance. So we have a good performance in terms of S11 and S2. For phase 15, we have a good dynamic range. For on the left side, we have electromagnetic simulation measurement for 2.4 gigahertz for different value of voltage. And on the right, we have different frequency and the phase as function of voltage of voltage. So we have proposed a mathematical model of different input sections, and good performance was obtained. Insertion loss is less than 1 dB. Best insertion loss at operation frequency, large variation of phase shifting. That means good dynamic variation of phase shifting. Thank you.
Thank you for this presentation.
Okay.
Do you have questions or comments? What is the maximum frequency changes?
For this 3 gigahertz. 3 gigahertz.
Have you tried to compare with other design methods for frequency shifters already?
Yes, and we try to realize in my work, because I write my PhD store. I have many examples of phase shifter.
Yes.
But for this presentation, I have not present or put comparison between our phase shifter and other for this presentation.
Any questions? Thank you. There is no question, so we are going to go to the next presentation. We usually will the same speaker.